Hi everyone. Okay, I see we have quite a few people still joining, so let's just wait a minute before we begin. Alright, it seems like we're just shy of a full house. Welcome everyone. My name is Leonidas Hanos, and I will be hosting this webinar. I know some of you know me, but for those that don't, I have been in the solar industry for 6 years. I started out working for an installation company specializing in residential and commercial installations. 2 years down the line, I moved into a market development role for a leading South African electrical wholesaler. I have been the head of technical support at Solar MD for the past 2 years. That's a little bit about me. I really want to thank you for being here today. So, what do you need to know to participate in this webinar? You don't really need to know much. That is what we are here for. I will be going through a slide deck and I'll elaborate on each slide. If you have any questions, you can submit them through the Q&A button. If you click on that, you can ask a question. We have a panel of engineers that can answer in real time as I present. You will get the answers in real time. If for any reason we do not get to answer your questions during the webinar, maybe it is an in-depth question that requires more time, we will email you after the time. Before we get into what we are going to look at today, let me give you a quick overview of SolarMD. SolarMD was founded in 2014 with a vision of empowering developing markets through battery storage and changing the way people utilize and monitor energy. The way we wanted to achieve this was by making our product beautifully designed, simple to use, future-proof, and by providing an elegant user interface that was easy to understand. We currently have a manufacturing ability of 20 megawatt hours a month. We achieve this through a well-oiled operation that consists of 4 pillars that operate as individual entities that tie into the main production facility to deliver the final product. Let's look at these 4 pillars. Mechanical engineering factory. Our mechanical engineering factory includes all mechanical preparations. That includes, but is not limited to, designs, laser cutting, bending, welding and conducting test correlation for components and multi-material systems. Our mechanical engineering factory is also home to the first laser terminal welding machine in Africa. Electronic engineering factory. Our electronic engineering factory designs and optimizes our in-house products, which include our BMS, EMS, and Logger V2. Our engineers inspect all electronic equipment, instruments, and systems to make sure they meet safety standards and applicable regulations. The electronic function is responsible for writing specification and drawing up theoretical designs to create user-friendly interfaces for our clientele. We also do all PCB testing, assembly, and programming in this facility. Software engineering. Low and high-end software development. We have an international team of experts that specialize but are not limited to embedded system engineering, server development, front and back end development. Our software team has also created quality control software that we utilize in-house for the production of all our products. Main assembly factory. Our main assembly consists of two streamlined assembly lines. This is where the product comes together. We have strict quality control measures that have to be adhered to. Our quality control software only allows a serial number to be assigned to a battery once all tests are passed. SolarMD is dedicated to empowering people through the latest technological advances in the field of energy storage and by revolutionizing the way man monitors energy consumption. SolarMD has over 150 years of combined battery experience, mostly in the R&D and technical support function. And a very large percentage of that experience has been acquired in various countries, which gave us a major advantage from the offset. This experience extends into mechanical engineering, electronic engineering, and software engineering. We've tested our batteries extensively as we started out as an installation company. This gave us the opportunity to complete over 700 installations across Africa. This has served as a benchmark for the development of our products, as our engineers designed the product to not only be robust and aesthetically pleasing, but to be easy to install as well. We developed our own BMS, and this is really a critical point because the BMS is really the brains of a lithium battery. Our hardware and software engineers could define the exact functionality which provides a level of control and accessibility that simply sourcing an off-the-shelf BMS cannot provide. I want to stress that anyone can buy lithium cells and an off-the-shelf BMS and string a lithium battery together. It's done. We've seen people online do it. Some companies do it. But when you do that, it is not optimized for anything in particular, and it is certainly not optimized for the demands of the African market. We had the opportunity of testing our BMS on a wide array of applications, and this gave us an edge in refining our BMS to perfection. Now that we've discussed our objective and how we have achieved some of it, let's look at some of the design considerations and inputs. Designing a solution from scratch was a great opportunity for us to provide the market with everything it needed and to solve the issues that earlier lithium solutions brought to the market. Here are some of the problems we solved. Obtrusive. The first solutions were made to be freestanding on the ground. We were the industry pioneers in offering wall-mounted solutions. Different capacities. We could not find a solution that could parallel different capacity batteries. We made this possible for our product. We also included busbars in our batteries for ease of use. No modular architecture. Most larger batteries were sold as one unit. This makes logistics in developing countries a nightmare. There are also no load sharing capabilities with that configuration. In other words, if the unit has an internal fault, the whole unit is down. Hot swap technology. We found that most batteries had over-complex battery management systems and internal components that were not easily accessible, thus making it impossible for a qualified technician out in the field to replace any component remotely. Ease of installation. We made our batteries easy to install. Our cabinet mount solutions are offered with cabinets that are pre-wired with integrated busbars. Our wall mount units offer a backplate that has the exact outer dimensions of the battery to make positioning a breeze. And they also offer integrated busbars, as well as 2 entry points that are tailored for 100 by 40 mm trunking. Energy as a service. We decided from the offset that we would be the best service providers in the market. When we transitioned into strictly production, we maintained our customer for life philosophy. Intelligent communication. Not only did we realize the importance of intelligent communication between all components in our batteries, but we developed software that made normal voltage-based inverters smart inverters. We also developed an artificial intelligence algorithm for all other smart integrations. Not only does this optimize performance, but it makes sure we constantly improve as all the information gathered in the algorithm constantly looks at increasing performance. Reliability. And then finally, reliability. None of the features would matter if the product is not reliable. So this was the core focus point when designing our products. Of course, there are many other details that were considered and included, but these are the main overarching factors in the design of SolarMD batteries to address what we saw is missing or limiting out in the market. So the bottom line is, the goal was to develop a product that was unobtrusive and elegant, could provide flexibility in capacity, had a modular architecture that provides load sharing between modules, so that in case of a failure, the output power would remain unaffected. We wanted to design a product that would make the replacement of any component fast and hassle-free. We designed a product that is easy to use for the installer, and most importantly, a product that is rock solid and reliable. And that is exactly what we accomplished. Product overview. Our flagship residential offering includes our SS4037 and SS4074. The SS4037 is a 3.7 kilowatt hour lithium phosphate wall-mounted battery, and the 7.4 the SS4074 is a 7.4 kilowatt hour lithium phosphate battery. We then have a SS202 unit, which is the 7.4 kilowatt hour battery in a rack mount solution for the commercial market. The SS202 also forms the cornerstone of our containerized solutions, which has been used for various utility scale solutions. Lastly is our Logger V2 that integrates various components in a solar system on one platform, facilitating remote data acquisition and device control with extensive battery information. Now, let's take a more in-depth look at the individual products. Firstly, we'll dive into the wall-mounted units, the SS4037 and the SS4074. The SS4037 and SS4074 have been widely used in energy storage applications in the African market. The elegant compact design achieves market-leading energy density that is scalable and allows for an unlimited configuration on the wall. The SS4037 has a nominal capacity of 72 amp hours. Its usable capacity is 3.7 kilowatt hours. The peak power rating of the unit is 5 kilowatts. The battery includes integrated bus bars, fuses, and our advanced battery management system with intelligent communication. The SS4074 has a nominal capacity of 144 amp hours. Its usable capacity is 7.4 kilowatt hours. The peak power rating of this unit is 5 kilowatts. Let's take a quick look at how easy it is to install the SS4074.
This video is intended to provide assistance for the installation and commissioning of the SolarMD 7.4 kilowatt hour wall-mounted lithium phosphate battery. Once the box is open, you'll find two plates on the top. I'll explain exactly how these are used once the battery is mounted against the wall. The next step is to open the battery cover to remove the safety bolt which secures the wall mount bracket. To remove the wall mounting bracket, tilt the battery in an upright position and pull the bracket off the back. The mounting bracket is the exact size of the battery's outer dimensions, making it easy to see where the battery will be positioned. It is important to make sure the mounting bracket is upright and level. Secure the battery using the mounting bracket bolt. The battery has cable entry points on both sides and offers a buzz bar with 4 connection points. If only one entry is used, the other can be covered with the L plate provided. To start the battery, first turn on the battery management system, then press and hold the main power button for 3 seconds. For inverters that require digital communication from the battery, you will need to use the Solar MD Logger V2.
It's really that simple. Next, we will look at the cabinet mount SS202. The award-winning SS202 design achieves market-leading energy density that is scalable and allows for unlimited configurations. This unit is easy to install, enabling owners to quickly realize the benefits of reliable, clean power. The battery's modular architecture allows load sharing between units, so in case of a failure, the output will remain unaffected. We offer 4 different cabinets to accommodate the SS202. A CB13, which stands for Cabinet 1-3, in other words, a cabinet that can slot 1 to 3 units. A CB14 for 1 to 4 units, a CB15 for 1 to 5 units, and a CB17 for 1 to 7 units. If we are involved in the design process, we usually oversize the cabinet, which subscribes to our future-proof philosophy. The SS202 forms the cornerstone of our bigger solutions. Let's have a look at some of the recent mini-grid solutions we've completed. A 1.15 megawatt hour mini-grid for a lodge in South Africa, a 2.25 megawatt hour mini-grid electrification for a village, a 1 megawatt hour mini-grid for a game farm in South Africa. Let's take a more in-depth look at the proprietary Solar MD Advanced BMS. As I mentioned earlier, the BMS is really the brains of the system. The proprietary Solar MD Advanced BMS implements an extensive list of features that is specifically designed to protect the battery pack. These features include advanced state of charge algorithm, cell over voltage and under voltage protection, intelligent cell balancing, battery charger control, temperature monitoring, monitoring the health of the battery pack, and accurate cycle count. Cells are protected from over voltage, under voltage, over temperature, and under temperature. Intelligent, efficient cell balancing is provided to maximize the usable range of the battery. Prismatic lithium cells perform best when installed upright. This also ensures their lifespan is prolonged. The BMS has been fitted with an accelerometer to ensure that the installation angle is never greater than 30 degrees from vertical and upright position. The BMS also monitors the health of both individual cells and the total pack and provides an accurate cycle count. If a warning is triggered, the BMS LEDs will indicate the warning. This is of great use to the installer and end user alike, as the BMS will indicate the exact error. The BMS has 3 status LEDs toward the top side and 6 at the bottom. If a warning or error is active, the front intelligent power button will indicate this. Yellow indicates that a warning is active, and red if an error is active. In normal status, the bottom 6 LEDs can be set to off, show current, or show capacity. The first 3 LEDs are yellow, to show discharge if current flow is selected, or less than 50% state of charge if capacity is selected. The following 3 LEDs are green, to indicate charge if current flow is selected, or more than 50% state of charge if capacity is selected. I will explain how to toggle between these functions when we look at the intelligent power button. These 6 LEDs will also be used to display the specific warning or error. Let's have a look at 3 of each to explain how the codes are displayed. I don't want to waste your time, so I'll not go through all the warning and error codes. Each battery includes a manual where you can have a look at the extensive list. Warning 1, indicated by LED 6, will let you know that the battery has a low cell voltage. Simply put, this means that the battery is at a low state of charge. Warning 2, indicated by LED 5, will let you know that the battery has a high cell voltage. Simply put, this means that the battery is completely charged and still receiving charge. Warning 3, indicated by LED 5 and 6, means that the battery charging current is higher than the maximum allowed charging current. This means that the battery is exceeding the 5 kilowatt power rating. We have specifically included slow blow fuses so that the battery can exceed this max for a short period. We have really made it extremely easy to troubleshoot. The battery will let you know exactly what is wrong if it is in warning or error mode. Let's have a look at a few of the error codes. Remember, the error LED on the top 3 status LEDs will indicate if it is in error state. Error 5, indicated by LED 4 and 6. Battery position x-axis is out of range. This means the angle on the x-axis is more than 30 degrees. The battery will have no output until it is mounted correctly. Error 6, indicated by LED 4 and 5. Battery position y-axis is out of range. Let's look at error 22. Cell voltage too low. This error is if the battery is in a critical stage due to low voltage. The battery will go into sleep mode and wake up every 2 hours to check for charge. You can also manually wake the battery up by overriding it on so that it can charge. Any warning or error that is flagged will also be time-stamped in the Events tab of the MyPower24 portal, making it easy to troubleshoot remotely. Now, let's look at the Intelligent Power button. As a standard, the button is set to display state of charge based on color. While displaying state of charge, it will also show you if the battery is charging or discharging based on the direction the color is fading. If the light is fading out or towards you, it is charging. If the LED is fading into the battery, it is discharging. The Intelligent Power button will also indicate warnings by the power button flashing orange, and it will indicate errors by flashing red. The Solar MD Intelligent Power button offers extended battery functionality. You can access these functions by opening the battery so that the BMS is visible and holding the power button in. This will take you through the menu, each of the 6 LEDs representing the following functions. To select an option, simply release the button and give it a single press to select. Option 1 is reserved. Option 2, change indication LED between show capacity, show current and off. Option 3 is reserved. Option 4 is wake up if sleep mode is active. Option 5, activate override off state for 60 seconds. And option 6 is activate override on state for 60 seconds. As discussed earlier, you can see option 2 will allow you to set the functions between the bottom LEDs being off, showing current or showing capacity. Option 6 will force the battery into on position if it has a low voltage error so that it can charge. The intelligent power button can also be turned off or to a static color of your choice. There are also advanced settings like static color with current flow direction you can access through the My Power 24 portal. That is it for the advanced BMS and its core functionality and advanced features. Now, let's take a look at the Logger V2. The Logger V2 differentiates itself as an intermediary device that integrates various components in a solar system on one platform, facilitating remote data acquisition and device control. Let's first take a look at the following video below, which will show you all the various connections, how to power the logger, and how to connect it to the internet.
Hi, I'm Leonidas, and today I'd like to take you through a step-by-step introduction to installing the SolarMD Logger V2. The SolarMD Logger V2 is a lightweight solution for remote data acquisition which enables users to benefit from advanced energy reports and device control. Before we begin, please make sure you refer to the instruction manual. Please follow the relevant safety precautions during all procedures. Step 1. Unpackaging. Once unpackaged, you should have the following: a quick installation guide for the most common inverters, the logger itself, and a Wi-Fi antenna. The package does not include a power supply, since the logger is specifically designed to work with 24 to 48 volt DC battery systems and can be directly supplied from the battery busbar. The front of the logger provides the following information: the serial number, Wi-Fi SSID, Wi-Fi password, and local IP. Step 2. Various connection options. Let's take a look at the various powering options and communication connection points. The top side has the powering options, Ethernet plug-in, 2 USB connections, and an RS-232 connection point. At the bottom side of the logger, there is 2 GP relays, 2 CAN bus ports, and an RS-485 connection point. Step 3. Mounting instructions. The logger has pre-drilled holes for easy mounting. A DIN rail mounting kit is optional. For reliable operation, it is required that the data logger be located within 100 meters of an Ethernet connection and within 10 meters of the CAN bus connection. Step 4. Powering the logger. Connect the data logger directly to a 9 to 65 volt DC voltage source. Alternatively, you can power the logger with a micro USB power supply. Step 5. Connecting to the internet. In order to gain access to the monitoring features, the logger needs to be connected to the internet. There are 2 ways to connect the Logger V2 to the internet. The first is to simply plug a network Ethernet cable directly from your router into the Logger V2 Ethernet 0 port. The second method is connecting the logger to an available Wi-Fi connection. In order to do this, you will need to connect your smartphone or laptop to the Logger V2 built-in Wi-Fi access point. The connection details like SSID and password are on the front of the Logger V2. Once connected to the Logger V2, navigate to the local IP address 192.168.222.1 in your browser. To log into the logger, use admin in lowercase as your username and password. Once the logger is accessed, you can connect it to the internet. In the main menu, navigate to My Devices, Logger My Power, Network, Wi-Fi. All available networks will appear. Select the Wi-Fi you would like to connect to and enter the Wi-Fi password. The Wi-Fi client tab will confirm once the connection is completed. The connection will also be verified on the logger by the network connection LED turning green. Step 6. Device registration. To register your connected device, simply scan the QR code printed on your logger using your smartphone. This will take you to the MyPower24 login page. If you don't have an account, you can simply select the Create a New Account option and follow the easy procedure to register. If you are an existing user, you can just log in and the logger will be allocated to your account.
That is how easy it is to connect the logger. Now, let's take a look at a demo account to get a live view of the MyPower24 portal. The dashboard provides an intuitive, easy to understand user interface. Starting from the left, we can see the grid with the daily total and the grand total. We can then see the PV production, the daily and grand total. We can see the consumption for the day and over the lifetime of the installation. The battery provides us with a state of charge. It will also automatically do a calculation to let you know how long it will take to be completely charged or discharged. If one of these sources is not available, it will simply be grayed out. At the bottom of the page, we can see the environmental benefits, financial benefits, and a quick overview of the energy usage. You have a daily, monthly, yearly, and total view. The financial tab provides you with your exact savings. You simply add your utility rate and it works out your return on investment. The energy tab provides a breakdown of where the load has received power from and where the solar production has been utilized. The My Graphs tab provides history data and a history comparison option. Let's take a look at the history data tab. As you can see, the portal is extremely responsive. This is mainly due to the latest technology our software team has based the platform on. Here you can get a weekly overview of your system. You can also navigate back in time to view any particular week since the inception of your system. This is where the History Comparator tab comes into play, as you can compare many weeks on the same chart. You can remove any specific data on all charts by simply clicking on the value. The Energy tab provides weekly, monthly, and yearly totals. The My Devices tab provides you with all connected devices. The first is the relays. These can be set to switch loads on and off based on the battery's capacity, discharging power, and a wide array of time frames ranging from monthly to the hour. The second is the batteries. Here we have extensive information about the batteries. The basic information in the first tab provides us the voltage, current, power, capacity, and the charge or discharge time. We can then see the temperature, total number of cycles, difference between the lowest and highest cell voltage, and the battery's output status. You can also monitor each individual cell voltage. The logger will also record the max charge and discharge currents, as well as the duration of these currents. Next, we will take a look at the logger itself. Let's skip right over to the interface tab. Here you can see the various connections we looked at earlier in the video. By default, CAN bus 1 is used for the battery connections. CAN bus 2 is for inverters that also utilize the CAN bus interface. You can see how easy it is to add a software bridge for the inverter you will be using. You can also use the interface statistic tab to confirm connections. Under the RS485 tab, you will see compatible devices, the Carlo Gavassi and SMA energy meters, and also SunGrow grid-tied inverters. All of the above mentioned utilize this protocol. As mentioned earlier, the intelligent BMS records all events. You can access these events in the Events tab. This is a great tool to use when troubleshooting, as you will be able to see exactly what time any events happened or when a device disconnected. This is a great tool to use when troubleshooting. Under the Settings tab, you will find dashboard settings. Here you will find various display options. The logger automatically detects for what application it is being utilized, and it will change the dashboard accordingly. The Logger V2 is also very popular amongst grid-tied installations for monitoring and control. You will also find the tariff settings on this page. Under Themes and Visualization, you can tailor the portal to your own so your clients engage with your brand on the portal. Certain privileges can only be obtained through attending the Solar MD Academy. Lastly, there is a chat function that is available to all users. This gives all MyPower24 users direct access to our team of engineers and technicians, greatly reducing the time installers have to spend on support, and also giving the end users peace of mind knowing that they will always have direct access to a panel of experts that can advise on their investment. SolarMD really differentiates itself from the market by offering a 10-year service and not a 10-year product. We constantly engage with all our clients through monitoring, fault finding, and our artificial intelligence optimizes the complete system to make sure there is a seamless operation. This webinar also forms part of the Solar MD Academy, which offers various courses to installers to maintain international and local good practice in the industry. I really want to thank you for joining me on this webinar. We have recorded the webinar and will upload it to our various channels if you missed anything. Stay safe and stay connected.